In this video, we're going to look at a problem that's a little bit beyond what you'd usually do in grade 11, but not very far beyond, and that will help us sort of extend or have a little bit of a challenge if we need a little bit of a challenge with some of the material right now. So Mojo, the helper monkey, 10 kilograms, is climbing between two telephone poles. There's the telephone pole, there's the telephone pole. Here's our monkey. I'm just going to use a box because I can't draw a monkey. The line connecting the two poles makes a 25-degree, oh, they're 10 meters apart, sorry, separated by 10 meters. The line connecting the two poles that he's climbing on makes an angle of 25 degrees with one of the poles and 15 degrees with the other pole. Determine the tension, or with the horizontal at the pole. Determine the tension in each section of the wire. In each section of the wire. So, if this monkey is suspended between these two poles, then what that means is all the forces acting on this monkey must add to zero, must balance each other out. So, if I had the easiest force to think about is the force of gravity. We can see that that's going to be negative 98 newtons. But there's other forces acting on this helper monkey as well, specifically the tension in the two wires. Before I try and put those on, what I'm going to do is I'm going to assign each a variable, and then I'm going to put them on in components instead of putting them on angles, because if we look at them on components, I think it's going to be sufficiently complicated or confusing. Also note that if this angle here is 25 degrees, this angle right here will be 25 degrees as well. So if I imagine the rope pulling off to the left-hand side with an angle of 25 degrees, remember this was 25, so this is 25, and I've assigned that one a variable x, then I can get that the vertical component of that force is x sine 25. Or 0.423x. And this one is x cos 25. Or 0.906x. Having broken that vector into components, I can put him onto the free body diagram now, and I don't have to put a force on an angle that's going to be confusing later. I'm also going to call this my negative x direction, so I'm going to say that that's negative 0.906x. Try that again. Negative 0.906x. So there's my force of tension from one of the strings. Now let's look at my force of tension from the other string. Again, if this is 15 degrees, and I go down here, then this is 15 degrees as well, from the Z pattern if you want. I'll call this one y. And so this is going to be y cos 15, and this is going to be y sine 15, opposite and adjacent. Just using a calculator to come up with these sine values, 0.259 y and (966x). Now you might be tempted to say, well, there's two strings pulling up on this helper monkey. Shouldn't those two strings just share the force of gravity evenly? As in, if it's a total of 98 newtons, shouldn't each of those strings then get 49 newtons in that direction, and then couldn't I use that to figure out what the tension is in the overall string? And it's going to work out to be close to that. But because those two angles aren't equal, it's not a symmetric problem. They won't be sharing the monkey's weight equally. One of the wires will get more of the monkey's weight than the other wire. So what we've done here is we've taken those two tensions, we've given them a variable name and broken them into components, And what that's allowed us to do is come up with a free body diagram that shows what's going on in each direction separately. Now, if the monkey's going to remain stationary, that means that the sum of the forces, that's a fancy symbol that means adding all things together, or sum of forces, has to be equal to 0. We need that to be true in the x direction and in the y direction. Since there's less forces in the x direction, I'm going to start there. It's going to be make a little bit of a simpler equation. Let me put that on as a x, but it's actually a y. I guess that mistake goes all the way back to here. So in the y direction, or not the y direction, sorry, the x direction, the horizontal direction, I'm going to call it horizontal because I've used x and y as another thing, so I'm going to change those to horizontal and vertical just to keep everything straight. In the horizontal direction, I can see that the two tension forces have to balance each other out. However much one is pulling, the other one has to pull back horizontally, or else this monkey is going to swing from side to side. With that in mind, I can use that to come up with a simplified equation for x or y. I'll do that in a second. But first, let's look at what's going on in the vertical direction. So I'm going to have that negative 98 newtons plus 0.423x plus 0.259y, and that's going to all add to 0. So what we can see is, because the problem wasn't symmetric, I couldn't just divide up that force of gravity evenly. So when I go to take them all into account, I end up with two systems, or I end up with a system of two equations and two unknowns. I'm going to use substitution to solve this system, although you could use whatever method you wanted. I'm going to start with the horizontal equation and bring it over and substitute it into the vertical equation. And again, it makes no difference that I'm, just because of the way the numbers work out, I'm just making everything positive. Then I'm going to end up substituting in for y. I could have substituted in for x just as easily. Now I have a very simple equation for y. I'm going to use that and substitute into this equation to get an equation just for x. Bringing the 98 to the other side. And then I'm just going to do all of this. So 0.259 times 0.938 first, plus 0.423. And so the tension force that I'm going to get in the wire is actually equal to 147 newtons. That's in the x wire. That's this guy. I'll substitute into this equation to get the y wire. So that's 138 newtons. And so, one more time, what I did was I created a diagram of the situation. I broke the forces that were in angles into components. Even though I didn't know their values, I simply used a variable to hold on to their values so that I could put everything in right angles onto my free body diagram. Recognizing that the monkey is suspended, I said that the forces in the vertical direction had to add to 0, and the forces in the horizontal direction had to add to 0. And then I used a system of equations to solve for the two tensions. So that means that this tension worked out to be 147 newtons, And this tension worked out to be 138 newtons. So there it is. That's how much tension would be in those wires. I guess it's interesting to note that both wires, because they're pulling against each other horizontally, are carrying much more tension than half of the monkey's weight. So they're fairly high tension in that situation.